look at comparing the MRSA percent antibiotic resistant rates across years, specifically for 2011 to 2014. Using your data that has the columns by state, we first need to create a new column with the difference score. So let's begin by double-clicking here and double-clicking again on the column. And we're going to call this difference for 2011 minus 2014 and press OK. And then I'd like to create a formula, edit formula, and I'm going to do 2011 minus 2014 and press OK. So you notice here that I've put the direction of the difference, 2011 minus 2014, in the name of my variable. And that way it's very clear how you've done the subtraction. Now, if you're in SAS, you can't have a minus sign in your variable name. You could use an underscore, or you could simply use a letter M. And I'm going to press OK. So let's do a distribution, analyze distribution. And let's take a look at 2011, 2014, and our difference score and press OK. And if we look at our distributions here, we can see that 2011 ranged from 27.3 to 73.8, and 2014 the minimum was 24.7 and the maximum was 69.2. We can look at the medians, which seem to be about 2% different. We can also look at the means, which look at about 47 or 45 and 49. So also, again, about 4 difference between the two means. However, one thing that we do need to look at here is actually our ends. And you can see that we have 42 states with data in 2011 and 46 with data in 2014. But we only have 41 states that have data for both years. So you simply cannot just look at the mean from 11 and the mean from 14 and make a statistical comparison from that, because this is paired data. That is, we have data within state. The state of Alabama, for example, was 62.9% in 2011 and 46.1% in 2014. The data from the state is inherently related. It should be the same hospitals every year, which would mean the same protocols, for example, same physicians, same labs. And so there is a relationship between or within the state, and it may not be appropriate to think of 2011 and 2014 as independent. And that's why we've created the difference score. We can go ahead and look at then the distribution for the normal quantile plots for all three if we'd like. And all I did was hold the command key on a Mac, or you could hold the control key on a PC to get it to do the normal quantile plots across the board. So the data in 2011 looks normal. The data in 2014 looks normal. We have ample sample size, and both of them for the central limit theorem, as well as for the difference, also does look normally distributed. In addition to that, we have a large enough sample size on the difference. So there's a couple of ways we can approach normality. We can say that we believe 2011 and 2014 are normally distributed, therefore the difference will also be normally distributed. Or we can take a look at the central limit theorem, which says sample size larger than 30, and we can assume the means will be normally distributed. Or we can look at the normal quantile plot for the distribution of the difference, and it also looks to be or meet normality assumptions. So what we'd really like to do is do a comparison of the difference score to 0. That is, has there been a change in the percentage, the mean percentage from 2011 to 2014? And specifically, we want to know if it's gotten smaller. Has it been reduced? So I'm going to go Analyze, Distribution, put my difference score as my Y. So here we want to compare if the mean of 2.69 is different from 0. And in fact, we actually want to see if this 2.59 is actually a reduction. So is this greater than 0? We've done 2011 minus 2014. So we want to see if 2011 is greater than 2014, or if 2011 minus 2014 is greater than 0. So go to the red arrow, click on test mean. We don't need to do anything here because we're doing a t-test comparing to 0. So we don't need to enter a standard deviation. We don't know it. We're not doing a z-test. And we're also not doing a Wilcoxon signed rank test because we're okay with the normality assumption. So all we need to do here is press OK. And JMP will bring up your t-test results here. And you can see that it's testing the mean to 0. This is our observed difference. So you can see here, here's our mean difference, and here's our actual estimate. We have 40 degrees of freedom. We're doing one estimate here for the mean difference, which means we've used up 1 degree of freedom. We have an observed standard deviation of 9.4, 9.3568. It's the same as up here. We get a t-test value of 1.77. And now we have 3 p-values to look at. These are the p-values that are associated with our alternative hypothesis. This is the not equal to, so equal to, not equal to set of hypotheses. This is the less than or equal to null hypothesis with the greater than alternative hypothesis. This is the greater than or equal to null hypothesis with the less than alternative hypothesis. Our question is 2011 greater than 2014? So a research question would be worded as, has there been a reduction in the rates from 2014 to 2011? You work that out to mean that if I take 2011 minus 2014, if 2011 is larger than 2014, I should see positive values. Under the null hypothesis of no difference, I would expect a t-score close to 0 or a large p-value. Under my alternative hypothesis of 2011 being greater than 2014, I'm looking for this p-value right here. It is less than 0.05. And so in this situation, we would reject the null hypothesis in favor of concluding that there has in fact been a reduction in the percent positive from 2014 to 2011 compared to 2011. We could give the mean difference of 2.6, and then we could give a 95% confidence bound here about the mean. Because we did a one-sided test here, we have a significant p-value. Note that our confidence bound does contain 0 because the confidence bound is two-sided. You could actually simply report the upper bound so that the difference would be greater than 0 and as high as 5.4 for the one-sided test. So you could report only the one-sided part of the confidence interval. Now, what about if we did the difference the other direction? So simply create a new column and look at difference 2014 minus 2011. Do a formula, edit that formula, 2014 minus 2011, and press OK. And what you'll notice here is that we get the same difference, absolute difference. One is positive here versus negative. Notice for Alaska, we actually don't get a score because they have 2014 data, but they do not have 2011 data. So we don't get a different score. But these are essentially giving us identical results with respect to the absolute difference in the years. We just have a negative sign if we do the subtraction one way and a positive sign if we do it the other way. Remember, if our question is 2014 less than 2011, our expectation is that this value will be smaller than this value. The 2014 will be smaller than 2011. Doing the difference this way, we should expect a negative number. We should expect a smaller mean value for 2014 compared to a larger mean value for 2011. That is, under the alternative hypothesis, we would expect negative numbers here. If we do a distribution on this difference and press OK, and then also ask to test the mean, again, equal to 0 and press OK, we can see here, let me pull up our comparator for this variable, and you can see here for 2011 minus 2014 versus 2014 minus 2011, we see identical standard deviations, identical standard errors. We see reversed confidence bounds. We see a reverse in our mean change. We see a negative value here for our change estimate, a positive value here. We see a negative t-test value because we're looking on this side. We see a positive t-test value here because we're looking over here. You can see that the equal to, not equal to hypothesis results are identical. And we can see that we flipped the p-values here. This is the one-sided test for 2011 being larger than 2014. This is 2014 being smaller than 2011. So always make sure you understand which direction you have done your math. That will help you understand what you expect to see, and that will help you pick your correct p-value based upon how you've set up your null and alternative hypotheses, and then look for the hypothesis that matches. So you see, if we, no matter how we do it, we would still come to the same conclusion that 2011 is bigger than 2014, or that 2014 is less than 2011. That is how to do the paired t-test using a difference score. Up next, we'll see how to do the paired t-test using an actual shortcut in JUMP.